Okay.
Sure
I
we did.
remember. This was the break class. You ready yet?
No, I need to be.
So what I want to do is do a little bit that I talked about for the teachers to do. I asked teachers to do when they actually did a lecture. Should we see it? So they're kind of students like you. So on Tuesdays, they come after school and we do some training. So I'm going to ask, it's a good time to test them, right? Do you remember what we talked about?
No.
In training?
No. Yes.
You didn't remember because
I remember.
you weren't in in-service training.
I
Remember what we talked about in in-service training?
I don't.
Regarding,
I don't know, what was the major thing in
Oh.
training?
Man, I was just thinking.
Lectures.
yeah,
Lecture design. Daniela, do you know?
I'm sorry, what?
Do you know what we talked about in in-service training a couple of days ago?
Oh.
About lecture?
Uh-huh.
How it's a global lecture and how the target goes in.
Maybe, sounds like you're almost there. Go ahead. This will be good for you to see, because then you'll see how lectures are supposed to be set up.
you start with a preview and then you move into the target lesson and then you
Right.
cognitively prod them
So
into the next
we
one.
have this part of, you've got it, this part of each lecture when they sit down and talk with you. We use lecture lightly because sometimes you just discuss things. And we call this part of it a review. This section of it is the target material, the stuff that you're teaching. And this stuff, we call it a cognitive primer. And that's the stuff that you're going to be talking about in the near future. So the next time, this becomes the target. And this becomes the review. So that's loosely what's happening. So your teacher will always go over what you've done before. Now you also use this process when your teachers are
Teaching?
doing even choral exercises.
Yes.
So they start out with something you already really know. But the thing that they do in the review is they go through it a lot faster. And sometimes they do something called elaboration. And then they'll move that in and relate it to the things that they really want to be teaching, relate it back to what they've already taught, and then they'll do another thing and head in to some things that you expect. So that and relate the things that remember what we called this? What did we call this one? Remember what it's
Like
called?
cognitive prodding or
Cognitive primer.
That's interesting.
And you relate that back to here. So you always relate what you've already learned to the new things that you're learning. And you can actually help out with that because you can ask questions about it. Yes?
Is the whole process called scaffolding?
Is this scaffolding? Scaffolding's kind of a big term. You could relate this to scaffolding, but this is an addition to it. You'll have a scaffold within this. This actually builds the scaffold. Okay, so think that we were doing before in mathematics. Everything you will learn up and through intermediate algebra hinges on this. We're waiting. What's this?
What you counting?
Counting. And we have how many ways of counting? We actually have more, and I'm going to show you some more. But how many ways have we talked about counting? How many? 3, 4, 5,
I say
6. We call these the 6 arithmetic operations, and they are
Addition, subtraction, multiplication, division, differentiation,
root taking. And remember that these, oh, I almost thought I stepped on something. No, that's good. So, remember that we count forward or we count backwards. Now, addition, even though you can group things and say, here are 5 ones and here are 6 ones, and I'm going to put them together. Oh, we're waiting for an important person. Here, honey, would you sit back there and keep Jessie company? Would you do that, please? Okay, see if you can stay here with me in place of getting distracted, all right? Okay, so, and really, so, this is really addition, right? Going in this direction is addition. Let's try a little addition. 1, 2, 3, 4,
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Here, let me show you this neat thing. Here's how we keep track of it. So we start out with really 0, right? This is what we call the empty set. So in order to put something in something, and only one of something in it, it has to be empty. Or else you already have something in it. So this is a really important concept. People didn't figure this out for a really long time. So it's 0, 1,
2, 3, 4, 5, 6, 7, 8, 9,
9. Oh! But we stop at 9. Because that's all we need. Cool. Because, oh, 0's up here. So once we've counted all the way through here, 0 through 9, we come up here again and we say 0 again, but we counted all the way, so now we're counting the number of times we've been through this. So this is just, and we've gotten all the way through, all the way through, all the way through, all the way through, all the way down here. And so this is 11,
12, 13, 14, 15, 16, 17, 18, 19, 20.
oh, because now we get to here. How many times have we counted all the way through? 2 times that we've completed
Wow!
it.
2 times.
Yes.
The 5 on 15, it looks like a 6. Like the 5.
Happier? Okay. So, this is really weird because if I go 2 and 1, because we've counted through this all the way through 2 times. Be with us, honey. Remember, you can't learn if you're not paying attention. Oh, and part way through 1 part. In a way, this is a fraction.
Whoa! That's interesting. How?
Where? Because this is 2 all the way down here, right? All the way down. 2, we counted through all the way 2 and 2.
Interesting.
Now, do you want me to make it really confusing?
No.
We call this a number, this is number, this is number, this is number. This number has 2 digits. This number has 3 digits. So this represents that we have counted through 0 to
595. Bingo.
This really says part of a fraction. So we have a big block of things here to go 0 to 99, all the way through. And then when we come to the next block, that is 100. We counted through 10 and 0 times. What this really says, we counted through 0 through 9, 59 times, and there's the part that we've gone through. Now, what's really interesting with this, is, will we ever run out of numbers to count things?
No.
No, because it just goes on and on and on. Now, the numbers that you read the other day, up to into the decillions, right?
Yeah.
That is a huge, unimaginable number.
My brain.
So we have efficient ways to count it. But tell me, how many unique meaning, very different from one another, digits do we use?
14.
Is this a digit?
No.
Yeah. Is this different than this digit?
No.
Oh, that looks pretty weird compared to that one.
Yeah.
Is it different?
Yes. Maybe no.
Jesse? Be with us. If it's too hard for you to sit together, then you'll want to move apart a little bit. But you're doing a good job, so you're okay. So, is this digit different than this one?
Yes.
Is this one different than this one?
Yes.
Is this is one number with how many digits?
3.
3. Is this digit different than this one?
Yes.
Is this digit different than this
No.
one? No. So we have 3 digits. 2 of them look the same. How many unique digits do we have? Do some of these look like some of those?
Yes.
Oh yeah, look at that one. Looks like
1.
this one.
All the way down.
Right. We're using these over and over and over and over again. How many unique digits do we have? Oh, I spoke too soon, didn't I? How many unique digits do we have? Shall we count them?
Huh? Yeah. Sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You guys, you didn't start at 0. You said 1 at 0.
Let's go ahead and read.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9. We're supposed to start from 9.
Think.
There are 10 numbers.
There are 10 unique
Numbers.
digits.
Oh.
And 9 is the 10th digit. Weird, isn't it?
Yeah.
And then what we do is we recycle these. We do them again and again and again. Now this is what we call a 10-base system, because we have 10 unique digits. Now some societies have used 12 that have been unique. Some have used 60. But most of us use 10. Do you know what a computer uses?
Technology.
2-base system. And it looks like this. That's not 10. That's really not 10.
That's 1.
That is another number.
That's 0.
But they can get really, really, really long. So you can have a switch on, right?
Mm-hmm.
You can turn the light on, we can turn the light on, or we can turn it off. There's just 2 positions, and that's what a computer actually uses. Do we have a switch on, or do we have it off?
We have it on.
Well, it's on now, but we could turn it off.
Yeah.
But now, if we were counting, that's what we're doing when we're doing here. We're counting. That's what we're doing here. We're counting. This tells us we've been all the way through once. This tells us we've been all the way through twice. And this tells us how far we are through counting again. Isn't That we should have known that. You should have known that in kindergarten.
No.
That's
I
what you
kind
taught in
of skip it.
Yeah. Well, this is actually how Suzette is doing it now. So with a 10 base system, we're able to get how many numbers? Unique numbers.
9.
Those are unique digits.
Oh.
Unique numbers. You know how this works? This kind of symbolizes infinity because if we follow this around, when do we get to the end?
Never.
Never.
Unless you cut it.
When will we run out of, you're doing a good job today. When will we run out of numbers?
Never.
Never.
It'll keep going on forever and ever.
Do your body
and ever
position
and
so
ever.
you're towards me, it'll make it easier. Thank you. Yes, a little bit more, a little bit more, a little bit more. Let her get her foot through. That is much better. Okay. So, what this is just different ways of counting. Some people will call this, multiplication kind of skip counting. But, if we go in this direction, 1, 2, 3, 4, will we ever run out of numbers? No. If we go in this direction, it's addition. If we go in this direction, 5, 4.
3, 2, 1.
It is what?
1.
Is that addition?
No.
Yeah, it's backwards addition.
It's subtraction.
Oh, look, we're going this way. Very good. So backwards addition is,
Subtraction.
backwards addition is,
Subtraction.
and backwards subtraction is,
Addition.
and backwards addition is.
Subtraction.
Now we use another word, inverse. Watch this interesting thing. If I take this, sitting up like this,
Okay.
and I invert it one time.
Whoa.
Whoa, it's upside down.
I know.
If I invert it twice, it's,
Same way.
so if I do one inverse, and then another inverse, it's right side up. So if I go in this direction, addition, go back in this direction, and then back in this direction, it's still addition. Now, so with the inverse of addition is,
Subtraction.
and the inverse of subtraction is,
Addition.
so if we do multiplication, remember multiplication was repeated addition. Let's go ahead and try it. 2. Add another 2 to it. And what is it?
4.
Add another 2 to it.
8. 6.
6. Add another 2 to it.
8.
Is 8.
Ton.
2 to it. And it is
10.
10, 12.
14.
Oh, we're missing an important person. 14, 16.
18. 36.
Excellent. Okay, let's count the number of 2's we have. 1.
2, 4, 5.
Now, watch this. This is repeated addition, right?
Yeah. Times thing.
And so repeated addition is?
Subtraction.
Repeated addition
No, multiplication.
is multiplication. Oh, we're missing some important people. This will be pretty easy if you pay attention, you watch. It'll be pretty hard
If you don't pay attention.
later on, even though you could understand it now. So, 2 times 1 is
2. 2.
or 1, 2 is 1, 2 is 2. 2 2's are 4. Or 2 times 2 is 4. 2 times 3
3 is 6. 2 times 4 is 8. 2 times 5 is 10.
or 5 2's. 5 2's
is 10.
Why don't you sit by Jesse for just a few minutes? Go. Okay, so 5 2's are 10. Let's see if that's true. 2, 4,
6, 8, 10.
Now watch this really weird thing. It doesn't matter whether we have 5 2's or 2 5's. 5 2's or 2 5's. 2 5's are what?
10.
Oh, we're missing an important person. Okay. So, it doesn't matter whether we go 4 times 2 or 2 times 4. Is it still repeated addition?
Yes.
Yes. So, in this way, we are doing what operation? Multiplication. If we go this way, it's division. Now, I'm going to throw a little curve at you, and I'm going to leave it for you to figure out. This direction is repeated addition. This direction is repeated subtraction. So 2 from 10 is 8. 4, 2. Subtract 2. What is it? 0.
Negative 2.
Negative
4. Negative 6. Negative 8. Negative 10. Negative 12. Negative 14. Negative 16.
And how far can we go in this?
Infinity.
Infinity. Yes, but this one on this side of that 0 is, listen, is this number smaller than this one? Is 2 smaller than 4 or less than 4?
Yes.
Is 0 less than 2?
No. Yes. Yes. Yes.
Is negative 2 less than 0?
No. Yes. Yes.
If you don't owe anybody any money, is that more than owing somebody $2?
Yes. 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 Yeah.
Yeah, think about it. Don't just guess, think about it. So, is negative, what's the next one?
Negative 3.
Negative
4.
Negative 4, very good. Tell me, which is greater, negative 4 or negative 2? How many people say negative 4 is greater? Don't be suck. Wrong. How many people say negative 2 is larger than negative 4?
Is it unit?
It is. Which is it better? To owe somebody $2 or owe them $4?
Better than 2.
$2.
$2.
Which is it better? To have $2 in your pocket or $4 in your pocket? $4.
Wait, yeah.
Now most people think that way. I don't know if everybody does. Well, that's really interesting. Now, division is repeated subtraction. Multiplication is repeated addition. Now, let's take this same thing. Let's do this first. Could we have done this with and sometimes we'll call this base. Most people would use this. How many 3s do we have here? 1.
2, 3, 4, 5.
Is this repeated addition?
Yes. Yes.
Is it?
No.
What's that?
Addition.
Is this repeated addition?
Yes.
Yes, okay, so let's try it. So this, of course, is
6.
3.
3.
And 3 plus 3 is 6. And 6 plus 3 is? Oh, we're missing some important people. 9. 9 plus 3 is?
12.
And 12 plus 3 is? 16. Is that right?
No. 15.
So it is
15.
15. All right, let's see if we can do this. Oh, look at this first. 5, 4, 3, 2,
1.
0. And this is 3, right? 0 3s happens to be
3.
0.
If it's 0.
0. 0. Anything multiplying by 0 is 0.
0. Oh, interesting. Or if we're going this way, 3 from 3 is 0. And you notice I didn't put anything there. Now, that gives you a little hint of the little mathematical dilemma that I presented with the 2s that I'm not going to tell you about because you're going to figure it out and you're going to tell me. So you get to think like a mathematician for a little while. But let's take a look at this. 3 times 5 is 15. Or 3 5s. 1 here, I need some help here. 1, 2, 3 5s are 5, 10, 15. Or 5 3s, and I need one more 3 here. So 3, got to get 3 up there. You got to get 3 up here. We need one more 3, right? 3.
Put 2 more fingers on J.
3.
Put 1 more
Take
finger.
one
6.
One more finger.
1 more finger.
9. She's having a hard time holding her pencil and doing it. So 3, 6.
Put 3.
Help us out.
6, 9, 12, 15.
Oh, that's cool. Thank you. So we, doesn't matter whether go 3 5s or 5 3s.
No.
Well, let me see if that makes sense in all things. So is 5 minus 3 the same as 3 minus 5?
No.
Oh, so watch, be with us. So this doesn't work in everything. But if we do this, 5 times 3 is the same as
3 times 5.
3 times 5 or 5 times 3. But it doesn't work with subtraction, does it?
No.
So that's really kind of interesting. So you kind of have to watch it there. And so we're going to go on a little bit. Exponentiation. Oh, is this too hard? Exponentiation is repeated multiplication. So if we're doing with exponentiation with base of 2, remember now, we're doing exponentiation, so that is
Repeated
multiplication. So it's really that same operator, but turned on the side. Is multiplication related to addition?
Yes.
Yes, is addition. Can we turn on the, or
It's right there.
There's no way I can see it.
There's one way how I am.
So let's count the number we have. 1. I can't do this without you.
1.
We'll wait.
1, 2.
One of the things I want you to do is be able to focus on what's important and know what's important. That wasn't important right now. So it's 1,
4,
3, 4, 5.
5. And this is going to be exponentiation, so it's going to be repeated multiplication. So, 2 times 2 is 4.
6.
4 times 2 is
6.
yes. 4 times 2 is 6.
Oh wait.
4 times 2 is 6.
No.
4 2s are 6. 8. 8 times 2 is
16.
and 16 times 2 is
32.
32. Now watch how this is interesting. If we go in this way, we're doing exponentiation, which is repeated multiplication. Oh, is this too hard?
I was doing it though.
Okay, so if we go in this direction, we are doing what? Exponentiation. So this is repeated multiplication. If we go in this direction, this is root taking or repeated division. Let's see how that works. 2 divided into 32 is 16. 2 divided into 16 is 8. 2 divided into 8 is 4. 2 divided into 4 is 2. So 2 to the first power is, go ahead. What's the question? Here, go sit by Jesse for a little while. That'll help out a little bit. This is 2 to the first power. 2 to the first power is 2. 2 to the second power. 4. 2 to the third power.
8.
2 to the fourth power.
16.
2 to the fifth power.
32.
2 to the sixth power.
64.
64. Now, we're going to put something on tape. We're probably going to put it on the internet. You kids just started a revolution in this. Because when we're going in this way, we gave an absolute proof, an irrefutable proof that root taking is the inverse of exponentiation. Now I go one step further, which you probably don't know yet, but it also states that root taking and logs are equivalent operations, just stated in a different way. Just like there were 2 ways to notate calculus. And that you don't know about, but you will soon. Okay, so let's see, repeated division. Let's see if we can actually keep this going. 2 to the 7th power is 2 to the 5th power.
32.
We'll wait. We need everyone. 2 to the 6th. 64. 2 to the 7th. 128. 2 to the 8th.
256.
256. 2 to the 9th. 512. See what happens with your head here. Can you do it? What's the next one?
1,032.
512. So we got 512, 1,024, 2,048, 4,196. Well, add it up for me. And how far can you go? Now, you'll be correlating this. What we're looking for is not straight memorization, but mental dexterity. Here, we're going to do one thing. It got a little hot in here, so when you're a little bit cold, you're actually able to focus better than you are when you're a little hot.
Really?
So this is counterintuitive, but we're going to kind of shake things up a little bit,
I want to get
and then we're going to sit down and keep going. All right, stand up. Okay, what I want you to do is listen to what I'm saying. I want you to wiggle around. Good, you know how to wiggle. Now, you'll follow the instructions, I'll tell you what to do. But you'll listen to the whole instructions, and then you'll do it. You'll wiggle around first. Don't do it. Not yet. You'll wiggle around, turn around 1.5 times. Or that's, if you turn around 1 time, that's 360 degrees.
Yes.
If you turn around half of that, so that's 1.5, that's 180. So I'm going to ask you to turn around. Well, what do you think I'm doing? I'm adding these up, right?
You did it backwards. You start at the 0.
But you won't in this sense. You can start at either end. There's a couple of kids that probably won't get this. We do the addition. 1 plus 3 is 4. Do a look ahead. Will there be a regrouping?
14.
Yeah. If there are 2 rows, what's the maximum you can regroup? 1. If there are 3 rows, what's the maximum where you can regroup?
2.
2. If there are 5 rows, what's the maximum you can regroup? 4. What's the minimum?
10.
0. Okay. So these are rows, these are columns. So I do a look ahead. Will there be a regrouping? Yes. So there won't be a 4. It'll be 5.
Which is 4.
And 8 plus 6. All I have to do, be with us, is think of the first digit. So that's a 4 because we've already regrouped the 1, right?
And
This is a 0. So you're going to turn around 540 degrees. Stand there for a minute.
Okay.
Remember, the first thing you're going to do, don't do it yet. You're going, when I say go, you're going to do, shake up a little bit. Turn to your right.
Turn to my right. Wait.
540 degrees. Look at the clock for a minute.
Okay.
And then turn around, stand for just a second, and sit down. Okay, and those people who can't do it, I'll give a reward to. We'll give a reward to. You'll earn your reward. Might not be a reward you want, but you'll earn it. Okay, go.
We got the clock, and then for a minute, and then sit down.
None of you did it. None of you.
Wait, I did
Not
it.
one
I did it.
person.
What?
Now, you were out of my line of sight. Did you turn around 540? We'll wait.
Yes.
We'll wait. we'll wait until you're all facing me, until you're all ready. Okay, now, go ahead. No,
What? Turn.
no,
Look at the clock for a minute, and then stand for a second, and then sit down.
no.
Wait, what? That's what exactly you said. Okay, right. Okay, shake
Okay,
around.
sit down.
Okay.
I'll repeat it.
Okay, is it too hard?
One of the things that's really important for you to learn in school is how to figure things out.
Okay.
And that's not quite figuring them out, right? Wait. So we'll do this. Some of this, we actually, when we bring kindergartners in, and we're deciding whether they're mature enough, you wouldn't be mature enough for kindergarten, no. We see how well they follow instructions, especially delayed instructions. This is a delay. When I give you a bunch of instructions, and then I wait. And serial instructions. That means one instruction after the other. So there are a number. Yes! You get, come forward. Yes! You get to. Yes?
You get.
Come on forward. Come on. Oh, she gave your seat up for you because you wanted to be there. Okay.
What happened?
So, shall I give the instructions again?
Yes.
All right. Get ready for the instructions.
Okay.
So the first instruction is to make eye contact up here. Good, you got through that. Now that wasn't a serial or a delay. The next ones will be delayed. You'll stand up, hold it for a few minutes. Oh, I have to start over again. Because now these are delayed instructions. Now your teacher will do a little bit of this. And he'll do it in connection with some content. So you'll make eye contact first, stand up. Yes, you can go over there and sit. It'll be easier for you to understand. And you may go right there and sit. You're okay. You can sit or you can sit in the seat. That's up to you.
Wait.
He gets, yes, yes, yes. Why? Because it was too hard for you to look at what they're all doing.
Wait.
That's how you learn, so don't worry about it. It's not bad, you're just learning. Have a seat.
Okay. I'm confused because I don't know where.
Ah, that's what you're supposed to do. Figure it out.
I'm just going to sit right here.
Okay. Okay, we're not ready yet. Lots of times, people say what they want, not with their words, but with their actions. So, oh no, we're missing one person. How about body centering? Did your teacher talked about that?
What?
Any teacher talked about body centering?
What? A little bit.
A little bit? Oh, well, somebody will explain it to him at recess or sometime. Don't explain it now. Okay.
Jakey.
What was the first instruction?
Make eye contact.
No, that was rhetorical. You're correct though. Put your hand down. Let's see if they figure it out. They almost have it figured out. Not everybody has it figured out. You got it figured out. Show me. Don't tell me. No, 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 no. The first instruction. Somebody got it. That was the first instruction. That's before I can give more instructions. Okay. So you'll stand up, and when I say go, you'll stand. Oh, yes, you may sit there.
Me?
Yeah. I know you were just trying to help him. No, let's next to Gessie.
Okay.
Thank you. This is partly how you learn. This is what we call connected consequences. It's not punishment. But why should we punish you when you're just show us that you need to learn a little bit more. Okay, are we ready for the first instructions?
Yes.
Oh my goodness, we got everybody doing it. Okay, when I say go, you will stand up. Are we sure we don't have the heat on?
Yeah.
Yeah. You'll stand up, you'll wait just a moment, you'll shake, stop, turn 540 degrees, look at the clock for a minute, and then turn around another 180 degrees, which means you'll be facing me, and then you will sit down and we'll be ready to go on, if I can remember where we left off. Okay, and which way will you turn?
Towards the clock.
Towards your right. Is this your right?
Yes.
Is this my right?
No, it's your left. That's your left.
Yes. Is this my right?
Yes.
So, will you, here, let me see if I can give an example. This is my right. Will she turn towards this way?
No.
She will turn towards her
right.
right. Did you notice, when I stand here, this is my right, that's her left. This is my left, that is her right.
Like when you shake hands.
Yes. Well, not quite. Here, stand up. When we shake hands, we don't shake hands like this usually. We shake hands like this, and this is right hand to right hand, or left to left. Now this is really funny. Her thumb's on that side, but if I use this one, it's opposite. Isn't that? It is what we call a mirror image. So if you put your hand up to a mirror, in the mirror, it will be the left hand, and on your hand, it will be the right hand. It's called symmetry, and we'll be talking about symmetry later. Now, what I did is just did a delay, made you think of something else. Now, my question is, it gives me an idea of what's happening in your brains, is, will you remember what the instructions happen to be? We wouldn't do this with kindergartners, but we'll do it with you. Does anybody have any questions? Yes?
How long will you shake?
Not very long.
Just a few seconds.
Just a few seconds. Yes.
So 2 seconds.
Okay, any other questions? Now, in the future, your teacher will ask you to do these kinds of serial instructions in sequence all together. So you'll watch the people, just for the fun of it, see if we can develop some of that skill. Go. Almost, we're pretty close. You guys did a really great job. Come on up. Have a seat. You're not supposed to sit down. Okay, so here we go. I'm going to erase that for right now. And I'm going to take a look at this. When we went in this direction, we were doing what?
Squares.
We're going this, 2, 4, 8, 16, 32, 64, 128, 512, 1024. Did I get those right? I don't know.
1096.
Good, you're going to, so what operation? Oh, we're missing an important point. Have a seat. See, this guy knows all of this right now, right? I think he does. I think you do, right? So, we're doing what? We need your help. What are we doing?
Powers of 2.
Powers of 2. That's one way to say it. That's good. But when we called it here, we called it
Exponentiation.
exponentiation. Now if we go this way and we're doing repeated multiplication or repeated addition. Oh, that's weird. Okay, but when we go this way, we're doing what? Exponentiation was this way. This way is root taking or repeated division.
Repeated subtraction.
2, yes. 2 into 64 divided into 64 is 32. 2 divided into 32 is 16. 2 divided into 16 is 8. Now, oh, wait a minute, I just noticed something.
What?
Here, we got a 2 here. And I guess if I'm going to keep this straight, can I switch things up a little bit?
Yes.
Make it confusing, but I better not. So I'm going to put the 2's down like this. No, I'm going to do it in a way that is a little confusing. We're going to end up going in the wrong direction, but this will be okay. So we got 2 here. And so this is 3, 2, 1, 0,
Negative 1.
negative 1,
Negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8.
and so forth. Okay, so let's try, and we'll keep going through this and see what happens. So 2 divided into 2 is
1/2.
2 divided into 2?
1/2. Wait, 1.
1. 2 divided into 1 is
1/2.
1/2, right?
1/4.
Oh, but let's see. Remember, 1/2
Equals 0.5.
just is, remember we talked about division? This means division. This is the vinculum. In this case, it's the operator. And 2 divided into 1/2. 1 is
1/2.
2, oh, 3.
0.5.
0.5. So this is also equal to 0.5. Is that the same as, how do we read this? 0.5 or 5?
2.
5. What is, not quite, but almost. 5 tenths. Is 5 tenths
Ooh.
the same as
1/2.
1/2? Wow, cool. Okay, so let's say this. 2 divided into 1/2. Now let me just, very good. So if we have 1/2, and we're dividing that 1/2 in half, we've got
1/4.
1/4. Very good. Now, sometimes people will say that's a quarter, but I thought a quarter was money. So that means the same as 1/4.
125.
And we're going to, very good, what we're going to do is we're going to divide one for the next one, 2 into 1/4. That makes this one 1/8. Very good. But let's go ahead and do the division here with this quarter. What goes on the outside? Help me out.
4.
If you're not watching, you're not learning.
4.
4.
1.
What are the 3 remainders?
Our remainder.
Our remainder. Decimal remainder. Fractional remainder. Now we're really talking about common fraction. So 4 into that will go how many times?
2.
2. Oh, we're missing an important person.
8.
And I can put as many zeros to the right of the decimal point, and it still doesn't change the amount. So this, let's see, 4 times 2 is 8. Division is repeated. Subtraction, we're missing an important person.
No, Sally.
Okay, now this is 2. I can either bring the 0 down or the 2 up, same thing, right? And 4 into 5. So this is 0.25, or how else would you read it? 25 hundredths. Very good. Oh my gosh. Oh, there's something weird going on here. Does anybody know what this one will be?
125.
1.
Over 10.
There it is up there.
1 over 10.
1 over 8.
Oh, this one's already 1 over 8. 1/16. Very good. 1/32.
164.
And 2 to the negative 7
is 128. 1 over 128.
1 over 128.
And then 2 to the negative 8 is 1 over 256.
Excellent.
And 2 to the negative 9 is 1 over 512.
Very good. And 2 to the negative 10 is?
Is 200. 1,020.
Yes, 1 over 1,024. Oh my gosh, there it is over there. Wow, that's really, really interesting. Now, of course, this is 1/4. Let's see if you can do this one in your head. When you learn, it changes your brain. If what your shoe doesn't change with learning, it will just get older and disintegrate. It will move towards chaos. You'll get bigger, hopefully. But every day you change a little bit when you learn. Oh! Did I ask you to come too soon? Yes. Okay. So, let's see if we can do this one, and let's see if you can do this in your head. If I do 25 hundredths, is that exactly the same as 250 thousandths?
Wait.
I just put a 0 on the end of it. How many, can I put a 0 on anything to the right of the decimal point and not change its real value? Well, let me see. Now we know it's going to be half of that.
So then it will be
Half of
125.
1 point
1.25.
25. How do we read that?
125.
125